Houston, we have a podcast. Welcome to the official podcast of the NASA Johnson Space Center, episode 32, African American History Month. I'm Gary Jordan, and I'll be your co-host today, along with Kai Harris, the lead budget analyst for Propulsion and Power Engineering Division, and the chair of the African American Employee Resource Group. Kai, thanks for coming on.
Hey, Gary. Glad to be here.
So we have these groups here at the center called Employee Resource Groups, and Kai here is the chair of the African American Employee Resource Group. So we teamed up to do a special episode for African American History Month, where we'll be bringing in 4 guests that specialize in different areas across the center to do 4 unique segments.
That's right. We're very proud of our Employee Resource Group, and we have folks with a wide range of skills. Today, we have guests involved in life support systems, an Orion flight controller, robotics engineering, and human health and performance.
Awesome. I'm excited that we can bring everyone together for this episode. So this is pretty cool because you'll see all in one episode how many things are going on at the same time. So, with no further delay, let's go light speed and jump right ahead to talk with our guests from across the center for African American History Month. Enjoy.
T-minus 5 seconds and counting. Mark. Launch commit lights are correct. There she goes.
Houston, we have a podcast.
All right, Kai, thanks for helping me open up this episode. But before we go to our first guest, I kind of wanted to set some context about ERGs, these employee resource groups. So if you can kind of start off by talking about what is an employee resource group here at the Johnson Space Center, and then about yours, the African American Employee Resource Group.
So the mission of the AAERG is to serve JSC as a catalyst to strengthen JSC recruitment, onboarding, retention, engagement, and development of African Americans at JSC, thus contributing to the maximum inclusion and innovation of the JSC workforce and enhancing success of the NASA mission and vision. We do a lot of outreach events to the community. We feel it's important to have a focus on the community, let them know that there are people out here at JSC who look like them, who work here. Kind of give them hope that they can also work here. We also promote STEM a lot. We bring in speakers, and we focus a lot on developing our employees. We have several training sessions throughout the year. We have speakers come in, and it's all about helping to make JSC an even better place to work.
Awesome. All right, well, I'm excited to kind of kick this off. So, all right, Kai, who is going to be our first guest today?
First is Antia Chambers. She's the Thermal and Humidity Control Subsystem Manager of the ISS and the Life Support Systems branch. She started here as a co-op and has worked on a lot of different projects in her time here. All
right, well, producer Alex, let's play the wormhole sound effect and get right into that talk. Okay, so you started your journey here as a co-op, right?
I did. I started... Basically, I went to the University of Texas at Austin, where I pursued a degree in aerospace engineering. But prior to that, when I was in high school, I participated in the Texas Aerospace Scholars Program. I believe they've updated it since then, the name of it.
Yeah, and, I think it's NCOS now. It's National Community Colleges that they bring. They bring community college students from all over the nation, I think, now, yeah.
Wow, that's awesome.
Yeah.
No, they, I remember it was advertised in my high school. Hey, NASA's looking for high school students to come to NASA and have NASA engineer mentors, and I hopped right on it, and I went to NASA for about a week. We had like a series of assignments up until that point, and spent a week at NASA and learned about the co-op program and how it was like one of the primary hiring grounds for students or for full-time employees, and I was sold. So when the very, very, very first career fair at University of Texas, I was a freshman, and the NASA booth was the booth that I went to first, handed my resume, and that following year, they were actually hiring sophomore-level students. I interviewed and was offered a co-op at NASA, so I was really excited.
All right, and a co-op is, it's a rotational program, right? So you go multiple times?
Yeah, It was called, when back in my day, the Cooperative Education Program. I believe it's now called Pathways.
Yes.
It's a Pathways intern program.
Yes.
But it's still the same thing. Basically, you would go to NASA for a semester or a quarter, depending on the school that you go to, and kind of rotate between NASA and your school until graduation. And on average, it kind of extends the graduation date by about a year.
Okay.
Which is well worth it, by the way. Any type of on-the-job experience that you can get, especially in engineering, to figure out, is this really, really what you want to do, the better.
Yeah, I was Pathways too, and
Awesome.
so I came in, but I was a non-technical major, so I did the 2 summers, 1 semester rotation, and so I was delayed by just a semester, but again, totally worth it because it's
and look where you are here.
Yeah, here I am.
Here
I am talking to super cool people like you. So you were a co-op going in as was it engineering? You have an engineering background?
Yep.
Yeah.
I was an aerospace engineer, and so I believe it was my sophomore year I entered into, and the first group that they put me in was the pyrotechnics area, and
Playing with fire.
That team is amazing.
All right.
And it was a great introduction to what NASA was. I remember when I first got there, I'm like, oh, Dr. So-and-so, because I thought everybody at NASA had to have a PhD, and then they let it ride for maybe a day because they thought it was funny, and then they're like,
They just leaned into I'm a doctor, yeah.
Right. But they're like, no, not everybody at NASA are doctors. And then I kind of learned about how diverse the workforce is, not only from an engineering standpoint, but in the levels of education standpoint and how they came together as a team.
Definitely. So is that where you transitioned into? Did you transition to propulsion, or did you kind of go into something else when you went full time?
Oh, so pyros.
Or pyro, yeah.
So what I did pyrotechnics for my first tour, and then my second tour was in the trajectory operations, and it was then the mission operations director. Now it's, I believe, the flight operations directorate.
Yeah, a lot of changes.
Yeah, big change. And then the third co-op tour was spent in aircraft operations director, which I believe has also changed now. So I was looking at more atmospheric flight, and then the final one was in the systems test branch in my current division, which is the Crew and Thermal Systems division. And we, the division kind of focuses on life support systems and life support for the astronauts and support for the crew. And so after I did my final tour in the Crew and Thermal Systems division, I was given a job offer once I returned to school, and now the rest is history. I've spent pretty much my whole career in the same division, but I switched branches within there. So
I see.
I went to the extravehicular activity tools. I went and I worked on the tools for Hubble Space Telescope, and then I moved to RCC plug repair, reinforced carbon-carbon, which is the material that the tiles are made of. The shuttle is now retired, but the leading edge of the wing of the shuttle, and repair tools for that. And then I moved to spacesuits. And then right now I'm in life support systems, so environmental control life support systems.
See, now you're just bragging because you're all over the place. So you started with pyrotechnics, then you got trajectory, then you're doing airplanes, then you're doing life support systems, and then you're making tools for Hubble. This is crazy. That's the most insane resume I've ever seen. But I wanted to kind of skip around to that part where you were talking about tools for Hubble.
Sure.
You actually designed because Hubble wasn't designed to be serviced, but
Right.
then you had to figure it out, right, because of the astigmatism. So what tools were you making? What were you working on?
So it was interesting with Hubble, how the project, when it was initially introduced to me, I was like, oh my gosh, these are old tools, because these tools were actually a set of tools that were already used for Hubble throughout multiple service missions. And so some of those tools were older than I was. And they actually had handwritten drawings. So they weren't even computer generated drawings. And so the idea is that you would get these sets of tools and get them ready for the next servicing mission. There were, however, some tools like the manipulator foot restraint, which required a lot more additional engineering, a lot more support, and so that became a a bigger project than was anticipated, and it's actually featured in the Smithsonian right now. If anybody wants to go and see it. What? after the final servicing mission with STS-125, they retired most of the Hubble tools, and some of them were submitted to the Smithsonian. So
right, because they had to be specially designed for that, right? Because
exactly.
it was such a unique sort of thing, and this you had to create. What was it? It was a foot restraint, a special foot restraint.
Yeah. So what the foot restraint? It allows the crew member. So the robotic arm of the space shuttle would grab the foot restraint. Mm-hmm. The astronaut would then lock themselves into place, and then the arm operator inside the space shuttle would pretty much put the astronaut on the end of the foot restraint in the location that they needed to work. And we ran into quite a few problems with the MFR trying to get it prepped for this flight from everything. It was probably a great experience in showing how hardware ages, especially space hardware, and then all of the updates that you're going to have to do in order to get it ready for flight. And so we failed thermal testing, we failed vibe testing, we failed all sorts of testing, and we had to do fault tree investigations, and we finally got the final product so that we could use it for Hubble.
Wow! All right, and then it worked.
It
right?
worked.
Then
it worked great.
It did what it needed to do, and the astronauts were able to go out and fix Hubble and get some of those awesome images that we see now for the past however many years. Incredible.
Yeah, it was a very humbling experience because they mentioned that if the MFR wasn't available, they would have lost hours of crew time and ability to do as much of the servicing as they would have been able to do otherwise.
Wow. Okay.
So no pressure.
Yeah. Right.
But it was great because we got a lot of chance to work with a lot of different centers. Kennedy Space Center for the launch and prep and stowing it on the space shuttle, and then of course Goddard Space Flight Center, which was the lead for the actual Hubble mission. So it was really great cross center work. Great teams that were involved there.
Wow, what an experience! So cool. But then you said most of your career has been in is it life support systems? Is that kind of what you're focusing on?
So I am in life support systems right now. The division that I'm in, the Crew and Thermal Systems division, they have branches. And so the first branch, when I was a co-op, I did the systems test branch, which the vacuum chambers that are very popular. I think it's one of the largest ones in the world, our Chamber A, where we actually tested Apollo. And then when I was hired on full-time, I worked in the EVA tools and equipment branch, which is where the Hubble tools fell. And then I worked into the rotated into the spacesuit branch, where I worked a lot with the new spacesuit or the spacesuit interface for the Constellation program, which is now Orion. The Orion project.
Yes.
And then from there, I rotated into life support systems, which is where I currently am.
Okay. And you have some cool projects that you've done there, right? One of the more important ones is the water recycling system on the International Space Station, right?
Yeah, they have. So water is very heavy and very expensive to launch.
Yeah.
We do launch it still, but one of the goals of the space station, too, is to try to develop, closed-loop life support systems, which are especially useful for long-term missions that are out of low Earth orbit. And so one of the things that we do is we try to recover water from urine, which is, a lot of people are like, oh my gosh, urine. But it's actually interesting. The water that we reclaim from urine is actually cleaner than probably any water that anybody on the ground will ever drink. And so I have not tried it, but we don't get any complaints that I know of from the crew, I guess. But at the time, what we were looking at 75% water recovery. Our target was about 85% water recovery, but the problem is that the more water you reclaim out of urine, there's salts that are left over, and so those salts can create precipitation when mixed with our pre-treatment solution. We pre-treat the urine. One, it helps stabilize the urine, and also so that we can actually process it. But the problem is that the pre-treatment we were using at the time was sulfate-based, and it would form a precipitate precipitate in the urine that was not ideal, and what it would do is clog up our systems. And so what we had to do then was we decided to take kind of the sulfate aspect out of it and make it a phosphate-based solution. And so we changed the pre-treat, which was still a relatively strong acid, not quite as strong as sulfate, so we had to make it a little bit stronger, so that we can increase our water recovery from the kind of 70 to 74% water recovery to about 85 to close to actually 90% water recovery.
Wow.
And so we're very, very proud of that. So just think that, of the urine, you're looking at, if you look at urine, 85% of that can be reclaimed as water and recycled, and the crew can drink it. They can do whatever they need to do that's water related on station.
With the cleanest water
The
that you've
cleanest
never
water
tried.
that I've never tried, personally. But it's funny, some of the engineers have water bottles on their desk saying, "Oh, this so-and-so's urine." It's just kind of a joke, but it's water. But it's a great team. It's great to see how kind of desensitized everybody gets to talking about urine, or really anything related to the human body. It becomes like, oh, well, how do we do this? How do we treat skin cells? How do we treat condensate? How do we treat, it's like, it becomes like, how do we integrate better the human body and everything that it needs? Mm-hmm. How can we make that more of a closed loop system relative to the spacecraft it inhabits?
Yes.
And so it's quite a challenge. And as a result, we have a lot of spin-offs as a result that we try to that we try to distribute to the general populace, I guess.
That's right. We always brag about one of the technologies in the water recycling system has been brought down and used in third world countries to kind of help recycle some of the water, or I guess treat some of the water, so it's drinkable, it's potable.
Yeah, it's the goal. Ours is a little more toxic, but we are looking at non-toxic forms in order to try to implement on a mass scale too. So yeah, we're
all right.
Water reclamation is definitely something that we're interested in. Of course, on this planet. And it's actually another example of, in the pursuit of trying to do closed loop life support on space station or any NASA endeavor, we get these kind of spin-off technologies that actually bring the rest of the world with us.
Oh, fantastic.
So,
So cool. And that's so you kind of mentioned, and I wanted to touch on briefly, is the ultimate goal is closed loop. And
yes.
that means that it's all feeding itself. The water, the air, everything is sort of being recycled. And I guess you can say the goal is perfection, is to do it in a way where you don't need to resupply anything. It's just kind of feeding on itself.
Limited waste is
Yes,
always our goal. Now, there are some missions that it would make more sense having open loop systems, just if they're shorter. But if we're looking at deep exploration, the more closed loop and less waste that we have,
Absolutely.
the less that we have to bring with us, the better.
Absolutely.
And so that's always one of the goals, the major goals.
Yes, because resupplying that ship that's far, far away is going to be pretty difficult.
Right. It's not like going to the local grocery store and saying, oh, well, let's just get some more water or get some more food. It's
Yeah.
like, how do we make it so that we're less dependent on outside resources?
Exactly. So I kind of wanted to end with the project that you're working on now, and that's ammonia emergency response. Is that right?
Yes, that's correct. I am currently, so we have on space station an emergency scenario. We use ammonia as a coolant on space station. And in the emergency scenario, there is a possibility that some of that ammonia could leak inside space station. And ammonia is very, very toxic to humans. And, it's 3,500 parts per million concentration of ammonia would lead to one breath to death. And at much lower concentrations, you can smell it. It would start degrading. You can't see very well. Ammonia loves water. And we're we have a lot of things.
Yeah, we're mostly water.
Right. And it also has a adverse effect on our skin at some of these concentrations too. And so as a result, my team helped develop the ammonia emergency response. How should the crew respond to this emergency event? And the emergency stakeholder community, we have large community that determined that we do need a way that we can scrub the ammonia from the air, as well as provide an alternate air source or air supply to protect their lungs and their eyes, in this case, as they're trying to escape from space station. And so how the scenario would go is that you would have an ammonia alarm on station. The crew would don a quick dawn mask, or QDMA, that has a pure O2 source, but it's only for about 7.5 to 15 minutes. So they're going to have to switch eventually.
Okay.
What they do is they close their hatches as they go to isolate their escape vehicle. They close the hatch, and this is the commercial crewed vehicles that we're talking about. And you close the hatches. The ammonia scrubber, which is going to be already in there, would be turned on. It would clean that environment. The crew would have to switch to a secondary source, which is going to be breathing air, because we're worried about flammability issues. So you're looking at maybe 23 to 24% O2 instead of 100% that their original source was. And so basically they would have to wait about 30 minutes is the target. 30 minutes or less to completely scrub that environment. And once the environment is clean, they can get off of their mask and they can get prepared to undock from station and return home.
All right.
And so that's the whole scenario.
So your job is to work on the whole scenario, or just the quick dawn mask?
So initially, I developed the scenario, pulled in all of the stakeholders, and it's a rather large community. We looked at operations, we looked at our different providers, we looked at safety, the flight doctors. Everybody came together, pulled together. I pulled together that story, and from there we were granted funding in order to build the ammonia scrubber, which I'm the project manager of right now, and then a technical type manager on the NASA side for the CCV, Emergency Breathing Air Supply, or CEBA, which is the secondary source that the crew uses in the vehicle.
All right. So you oversee a lot of it then. Yeah. Wow.
And so it's a lot of integration, but I'll tell you, the teams are impressive. Everybody's goal is the same. They want the crew to be safe and return home, and everybody's motivated to that end. So it's great to see a plan come together.
Yeah, absolutely. Wow. What an amazing scenario. Hey, Antia, thank you so much for coming on and kind of sharing your experience. So cool. What an amazing career. Thank you so much for coming on.
Thank you. Thank you for having me. I really enjoyed it.
Of course. All right. That was awesome. Talking with Antia, she kind of made me feel like I needed to improve my resume a little bit. All right, so Kai, who's next?
Next is Gavin Guy. He's a robotics engineer working in the Software, Robotics, and Simulation Division. He started working at JSC after getting his BS in Electrical Engineering from the University of Houston. Go Cougs. And has now been full-time at JSC for a little over 3.5 years.
All right, let's go right through the wormhole to that talk. Go, producer Alex. Okay, so Gavin, thanks for coming on. So did you start as a co-op or an intern?
I started as a co-op in fall of 2011. That sounds right.
All right, cool.
Yeah.
So another co-op that we have here. We just talked to Antia, and she was also a co-op. Me too. So great program.
Yes.
Definitely gets you in the door.
Does.
So did you do all of your rotations in engineering?
I did not. My first rotation was in the spacecraft software engineering branch, which is in the same division I am in now, but a different branch. And then my second one was in FOD, where I worked with the Spartans. And then my final one was in the Year 5, which is my current branch, the Dynamic Systems Test branch.
Okay, so a little bit of the same division, but then you kind of dabbled in flight control for a little bit, right, with FOD as a Spartan, and they do the thermal systems, right?
They did at the time the external thermal and the power systems for ISS.
All right, cool.
I might be wrong on that.
But now you're in, and that's our org code, I guess, is ER5, and that means engineering, and then for the robotics, what is it, software, robotics, and simulation division? Is that what it is?
Yes. I sent that in there. I never remember. Software, robotics, and simulation division, yes.
Okay, so you kind of work with some robotics for space station primarily, right?
So my group is robotic test systems, and they support either tool development, like a payload development, or station testing and analysis. For instance, if something like one of the tools, like a robot microconical tool, had some issues, or some unknown things that weren't fully understood, and we did some analysis on that using our engineering unit and our test systems to understand and analyze the situation and try to give some feedback as to what that could be and best ways to move forward.
Okay, cool. So one of the pieces of equipment, and this is very visual because you're doing all of this in a lot of the work in Building 9, right? And Building 9 is our sort of playground, I guess you can say. Yeah, you got the mock-ups of the International Space Station, you got mock-ups of the Orion, but then you have this whole robotic side where you have all of these, all these robotic elements that you've built over time, but then also places to test some things. And one of them is Argos, right?
Correct.
So what's Argos?
So Argos is our microgravity simulator.
Okay.
That stands for Active Response Gravity Offload System. It's easiest visualized as an overhead crane system for people, but it's fully robotic. Has a pretty good control system. It has a vertical and a horizontal component, and the vertical component it has inline force sensors, which keeps track of the payload attached to it, and it can simulate either the Martian or lunar gravity or different microgravity situations. And we've used it for testing things like Robonaut, which is on the International Space Station. They have an engineering unit, and they test out some of their ISS operations in Argos. We've done suit evaluation testing, just understanding the suit requirements in a dynamic gravity offloaded test setup. And we've also supported things like rovers, like we have a resource prospect rover here at JSC that we're working on, which is supposed to be a rover that does drilling operations sometime in the future.
All right.
So
you put it on this system, this Argos, and you say there's a payload that goes in it, and that is the thing that you're testing, whether it's a person in a suit or the robot or whatever.
Exactly.
And then it can kind of simulate whatever gravity you want to program into it. So microgravity or lunar gravity, Martian gravity, that kind of thing, right?
Exactly.
Okay.
Exactly.
So what are some of the tests that you've been kind of setting up? I'm sure it's like this big crane system, but then you kind of have this floor where you can set up a test or practice something. So what's some of the things you've been running?
So lately, they've been doing things related to our alpha magnetic spectrometer.
Okay.
Which is AMS for short. It's currently they need to do some EVAs to repair some things on the deployed system, and they've been testing out their essentially their steps, right? So it's better to understand those kind of things on the ground, where things are easy to say, oops, we didn't plan for that. So understanding, like, if you're coming into something in a gravity offloaded scenario, these are the things we're going to try to do. And with our suits, the specific suits we're using for EVAs, these are our limitations for this specific task. Expect this when you're doing it, and they can kind of practice that here on the ground and understand it better before they send tools or do the procedures that they'll do on the day of the EVA.
That's right. Okay, so you kind of set up where the alpha magnetic spectrometer is on the station and kind of here's going to be the lay of the land when you actually do the spacewalk. And then you kind of run through your procedures to say, okay, I'm going to grab onto this handrail and fix this element in this position.
Right.
And then if that doesn't work, okay, maybe we should switch the procedures to do maybe a little bit of that.
Right. So it gives the team that's developing the procedures and the tools and the supporting the EVA effort a test system to really understand what's going on and the scope of that work.
So it's pretty collaborative then. You guys are working with the extravehicular office, right? You're working with some of those guys who are developing the procedures and all doing this test together?
Right. So I think the main people is EC, but I don't really...
Another engineering branch?
Yeah.
Yeah.
So there's also EVA involved indirectly, I'm sure, and even directly maybe. But it's pretty. They learn a lot from doing these kind of things. So.
Cool. Is there a lot of changes that go with Argos? Are you kind of reprogramming it or adding new features to it? Is it kind of a ever-going project, or is it this test bed that you use and it's pretty good and runs well on its own?
We go through different phases, right?
Okay.
So currently we're in a pretty we're in an operational phase where we're mostly supporting test scenarios. But there's definitely improvements we can make in the system. It has great capability right now, but we have ideas for upgrades and things. So we always continually try to research and develop as we go. But it is fully operational, human certified test system that we have in Building 9.
All right. Yeah, human certified, right? Have you ever actually strapped yourself in and gone on a run?
I have actually. Yeah, fairly recently.
Is it different? So you've actually kind of felt this simulated was it microgravity, or did you do another type of?
The microgravity.
You did micro.
Yeah, in the horizontal configuration.
Okay.
Yeah.
How was it?
It was great. It was a great experience for sure. So I simulated going across ISS using the handrails, and kind of what that's like, and so it was awesome. It was a great experience. I was free floating, with able to push off with the single finger and just feel like I float, which is nice.
Wow. Were you fully suited up, or were you kind of?
I didn't do the full suit.
Okay.
So I was doing it's called short sleeve. It's kind of just like your regular active wear type scenario.
Oh, okay. But it's kind of cool because you said you can just poke. You can just poke, and then your whole body will float in another direction.
Yep. And then laws of physics kind of are simulated within the system. So, if there's nothing to stop you and you're offloaded in the environment, then you kind of just float away.
Did your body get used to it pretty quickly, or was it very new and hard to adjust?
For me, it was fairly new and hard to adjust. So, and I think if you're not used to it, you don't use your body efficiently. And so it's actually a workout, right? So it's like, oh man, I don't know how to exist in this environment. And I think I'm supposed to use muscles, but the astronauts seem to be fine when they're in there, or the crew, the ASCANs and the crew members that interface with our system. But
particularly the flown ones, or even just like astronaut candidates that haven't flown, but just they're that good, I guess. I don't know.
Yeah, at least from better than me is what I would say. Yeah, so.
I'm sure the flown astronauts probably have the easiest adjustment. Like you strap them in and they're ready to go. They're moving around like an ice skater on ice or something. I don't know.
Yes, definitely.
Yeah, very cool.
So it was awesome getting in. I think before I came to NASA, at the University of Houston, I was like early on, like, oh man, I really want to work for NASA. They're working on cool, innovative things. And so I think a year before I got co-op offer, I received a call from the Argos project manager at the time, which was Larry Dungan. And he kind of told me what it was about. And I was like, oh, that'd be awesome to work on. And now, many years down the line, I'm working on a system, which is pretty cool.
Wow. Yeah. All right. So your introduction to NASA was someone actually calling you up and saying, hey, this is some of the cool things you can expect here.
Yep.
Very cool. So what other things can you find in Building 9? Are you working exclusively in Building 9 on different projects, or are you kind of working on other places?
That's the main things I've been doing lately, is in Building 9. So one of the other projects I support is a dexterous manipulator test bed, DMT.
Okay.
So that's a robotic manipulator. We're going through an upgrade effort at the moment. We had a 2-arm hydraulic system before, and it was mainly used as a test bed. People have used it for things such as understanding things that Dexter, which is on International Space Station.
Yeah.
Our special purpose dexterous manipulator.
Yeah.
To understand how payloads interface with that robotic system, and kind of understanding what forces they can tolerate in terms of insertion forces for doing change out operations for our batteries on the station and different ORUs. And so we're going through an upgrade process where we're going to put in an electric arm. In the past, we've typically tested only one arm at a time. So we've kind of gone from a 2-arm system to a 1-arm system. And we're going to go in and, of course, keep our dynamic simulations in the loop. and so that we can understand how best to send up ORUs or evaluate new payloads or understand things that need to interface with robotic manipulators. Really.
All right.
So it's going to be a pretty cool capability.
Yeah, that's great because EVA is or spacewalks can be sometimes a little bit dangerous. You can say. I mean, it's there's always the chance of a micrometeorite impact, and you have to make sure you go through the procedures. And astronauts are very good at practicing for those to understand what's going to happen and how to do the maneuvers. But if you can do the entire thing robotically, the Dexter goes on the end of the station's robotic arm and can do actual swaps. They can replace components of the space station without astronaut involvement. They can be inside doing science while this robot is fixing the outside.
Right.
That'd be cool.
Definitely. And on unloading cargo vehicles as they come up and things like that. And so as ISS moves forward, they're going to need to try to use that capability as much as they can. And so,
yeah. Well, I'm just thinking I just want one for my house so I can just kind of repair different parts of the house, and I don't have to. I could just sit and eat and watch TV and have this Dexter doing all the work for me.
Yeah, that'd be awesome. Yep.
All right, one thing before I let you go is one of your current projects is it's called a habitable airlock. Is that what it is?
Yes.
Yeah. What's that all about?
So habitable airlock it's a cabin concept that we're working on here at JSC, where typically as astronauts need to go do EVAs, they have to go through an airlock, and they're typically trying to adjust their pressure environments, and they have to spend several hours getting accumulated to where they're going to go to. So in general, there's not a lot of functional things they can do in that airlock while they're doing that. And the goal for this habitable airlock is to make it so that while they're doing the getting in the process of having to prep for an EVA, they can exist and be habitable and still do like science tasks and still be functional during that time. So they can essentially just use it as they would use any other part of their system. And so it's supporting our Deep Space Gateway mission that we're exploring, and so it's supposed to be pretty cool. We're on that right now.
That's great. So it's designed for a microgravity environment, and rather than like a planetary airlock. I guess between the habitat and the outside where you would do a spacewalk. This would be a kind of a test for the Deep Space Gateway. That's pretty cool.
Yeah.
All right. A lot of cool projects going on in Building 9. Well, Gavin, thanks for coming on and telling us a little bit about what you do. This is awesome.
Yep. Thanks for having me.
Of course.
Definitely.
All right. That was awesome. I felt like I was riding on Argos while he was talking about that machine. So, Kai, who's going to be our next guest?
Next, we have Mohammed Saibu. He's a flight controller for the Exploration Mission Program, Orion Space Vehicle for EM-1. Mohammed also has a bachelor's in mechanical engineering from Georgia Tech University.
All right, producer Alex, bring us through the wormhole. Okay, cool. Mohammed, thanks so much for coming on. So you are working to become a flight controller for the Orion spacecraft, right?
Yes.
So I guess there's a lot of you, right? Is there a whole group of people training for this one mission, EM1?
Yes, so we have some of the past shuttle flight controllers coming back on board, and now they've transitioned to the exploration mission. Mm-hmm. And in addition to that, we have a new group of flight controller, millennial generation, that we all got hired around the same time. A tad bit older than us, but I think we're all in the same age range. And right now, we're all certifying this year, hopefully certified by the end of this year, to become flight controllers for the EM1 mission. That's
awesome. All right. So we got, I know a couple friends of mine actually are over doing flight controllers for International Space Station, but this is a totally different thing, right? This is for the Orion spacecraft. So what's this EM1 mission? What are you training for?
So the EM1 mission is to fly Orion. I don't think so. If you're not aware of what Orion is the next United States space vehicle that's gonna fly beyond Earth's orbit, beyond Earth's low Earth orbit now. Okay. And I think so the first mission, EM1, is unmanned crew. So I think so this kind of testing Orion and giving us a high level objective to see, okay, is it safe enough to put a crew on board. So I think so. EM1 is the first mission, is scheduled to fly in 2019, followed by EM2. I think so. We can talk about that later. But
yeah. So you're training for multiple missions then, or are you training exclusively for Exploration Mission 1?
So I think so. Right now, how the transition, I'm speaking vaguely, but the goal is you train for EM1 and you get certified that for exploration.
Okay.
And hopefully you get grandfathered in for the future exploration mission because you've done a rigorous training, and hopefully they won't fly too far apart.
That's right. Well, it's kind of, so you're training to, it's called flight controllers because you guys are monitoring all of these different components of the flight of Exploration Mission 1. So what, are you training for something specific, or are you training to have a more broad aspect of flight controlling? What's your training like?
So I think so. It's a myriad of things to really talk about that, because it's not only focusing on one technical aspect, of course, like the monitoring the vehicle, understanding what's going on as it relates to spaceflight, but also getting some of the soft skill that you don't really practice on a daily basis, as being concise and talking to a lead director, making sure that you get across certain information and you don't give the excessive details. So I think so it's a more of a overall perspective of building you up, not only as an engineer on a technical basis, but also as a concise interpreter to talk to people. So I think so.
Yeah.
Both sides of the ball game or the coin.
Yeah, and then it's pretty translatable. So you can, I guess that would be translatable to future missions. So if you train for Exploration Mission 1, you'd be able to say, okay, I could do similar operations for another exploration mission because you get these skills. So you're training to become a flight dynamics officer, right?
Yeah, it's the FIDO.
Okay, so what's FIDO?
So FIDO, I think so. The FIDO is the flight position. It was really exclusive for shuttle when we were flying on the shuttle days, but our primary purpose is to monitor the vehicle from launch all the way back to entry. And by monitoring, we're monitoring where is the vehicle's position, the velocity, make sure we're in the right velocity, the orientation of the vehicle, just make sure that it's dynamically suitable for flight wherever we're positioned it, from all the way from launch, even pre-launch. I think so. We verify a lot of things. Like, I'm not going to go into the technical stuff like the loads on the vehicle, to the launching of the vehicle, to even on orbit, and final reentry when we come back down.
Okay, so there's a lot of different things to monitor. So the FIDO is monitoring it sounds like more location, right? Where is it? And then you're reporting to the room. This is where it is, right? Yeah. Okay, and then the velocity, make sure it's the right speed, because all of this is planned ahead of time, right? All of this is, at this point, it's going to be at this velocity and things like that, right?
Yeah, to a given extent, I think so. Okay. Plus or minus, of course, like nothing ever goes as planned. I think so. You have seen that in the flight world. In the space world, of course, we protect to a certain extent, plus or minus. We predict us to be at a certain velocity to make it there, but
yeah. And just talking to different flight controllers, it seems like one of the hardest aspects of becoming a flight controller is not so much everything goes according to plan. It's preparing for, if something were to go wrong, this is what you would do, right? So are you training in simulations where something goes wrong and you have to sort of yeah.
So I think so. A lot of that we're even doing now. So I think so. We're not as far ahead as ISS going on, where they can have a lot of integrated sims with multiple people. So right now, each division or each discipline are having internal sims. Like, we have paper sims right now. And the focus of the paper sims is not only on learning the technical tool that you use every day, but making sure that communication, like the soft skills that you talked about, are appropriate, where you talk to your flight or the flight director or whoever you're reporting to, and you're concise. You give them what information they need to know at that time. Of course, you can talk for as long as you want to, but sometimes a lot of the information is not necessary. So I think so. Being more concise, learning the protocol and how to talk on the flight, I think so. It's definitely a protocol to talk on flight. And to be honest, like, I'm sure you know about it in talking to your friends that are flight controllers now. The hardest part of being flight controller is not learning the technical stuff, but it's really showing that you have the discipline in some of the soft skills and talking on the loops and there, because that's where a lot of people just get whined out. Yeah,
because if you have to make sure you're communicating. That's the whole point of mission control, is to make sure everyone is talking to each other and everyone is aware of the situation and things like that, making sure that you have a great relationship, I guess, with your fellow flight controllers, right?
Completely agree. I think
Yeah.
so. The relationship is key, and that's what we try to build upon in the pre-flights. And people from shuttle days, even talking to the older, more tenured flight controllers there, that was one thing they focused on. I think so. Leading up to flight, it's not only getting to know your tools, knowing your flight rules and how you operate the vehicle, but knowing the people that you work with, knowing how, not knowing them like the back of your hand like a TikTok, but just knowing the soft skills there, learning the soft skills, learning what you need to improve on. So, because they tell you by the time it comes to flight, you guys are more of a family.
Yeah.
You guys are more of a family, and you know how each person operates there. So I completely agree with you on that. So that's one of the main things that we try to focus on.
So during your training, are you sitting with, I guess, a shuttle expert, a shuttle FIDO? Is a shuttle FIDO kind of training you and telling you all of these, like, literally saying these are the soft skills you need, these are the skills you need? Do you have like a mentor in this whole process?
So I think so. That's one thing I love about my division and where I work in the FIDO group, and I think so it's a dynamics division there. We're fortuitous enough to have an ample amount of FIDOs who have served in the shuttle days, and even some people who have worked some of the first few shuttle missions.
All right.
Shuttle missions. So I think so. We're just fortunate enough to just gain all that knowledge there, and of course every new FIDO is given a more tenured FIDO as a mentor there. So they work with them, and we have weekly to monthly meetings up to each individual to just learn, soak the lessons learned that they had in their earlier days and try to transition it to what we're expecting to face there. So yes.
Yeah.
So it's just been a great opportunity.
So what things have changed just between a FIDO that was training during the shuttle days and now for this new future exploration of Exploration Mission 1? I'm sure technology has progressed. I'm sure that maybe there's been lessons learned along the way that have changed. What are some of those changes?
So, of course, I think so. Anybody can say this along the line, just even looking at it, technology is completely different.
Yeah.
Like, we have so much now that they didn't have that day. The training flow is a tad bit more condensed just because of the timeline. Of course, we tried not to be, because with shuttle, they had sims back to back. They had so much time and an ample amount of people to just like train flow. So
Yeah.
you really got tested versus now with explorations, we're trying to do the best that we can. Like I told you before, a lot of the training is not as advanced as ISS or shuttle was back in the day. We're trying to build it on the go, but still keep that sense of detail to ensuring that everybody's trained appropriately, and we're not putting someone who's inappropriately trained on flight there. Because of course it's the best of the best. If you can't talk on the loops, or if you don't know the technical material, you will not fly.
Yeah.
So as far as changes, I think so technology is one. I think so the training material is another one. Of course, an increase in training material. You have to make sure everyone is competent. Even the older FIDOs have to make sure come along with technology there, and the timing is more shorter than before there. So I think so those are the main two I could say. So I think so as far as technology and timeline.
Yeah. Wow. A lot of changes, but it seems like, you have so much mentorship and so much experience with you that I guess you can say it's a little bit easier maybe, because yes, this is a new type of mission, a new form of exploration, but you can take some of those lessons from the Apollo days. You can take some of those lessons from the shuttle days and kind of fit all this experience into this mission. And it's kind of comforting to know that whenever this mission flies, you're going to have, like you said, the best of the best in that room, monitoring the spacecraft as it goes. So who else is in the room? So you got a FIDO. FIDO is monitoring the vehicle itself. What other console positions are there for EM1?
So I think so in addition to FIDO, a lot of the console positions are just as similar to shuttle, such as we have someone responsible for GNC, guidance, navigation, control. We have a prop guide, propellant officer. We have thermal guys there. So a lot of the flight controls in shuttle mimic are the same supporting Orion.
I see.
We have a landing support officer. Like I told you, we have an ascent FIDO for the launch, then we have an orbit one, then we have an entry one.
Okay.
Those are 3 different positions, 3 different disciplines.
Oh,
you have
wow.
the flight director who kind of coordinates everything and all of the flight controllers report to the flight director to give him a report on the status there, and he kind of siphons through the information to direct what's going on there. And Yeah, we have a PAO guy, public affairs guy is always there, just to make sure that we get everything. We have doctors there, doctors and surgeons to talk to the astronauts there. We have a power guy there, so I think so. Those are just like I said, I can go on for days on the positions there, but I think so. In summary, we have close to the same amount of flight controllers in the shuttle days, position-wise, as for exploration.
So how about EFT1, Exploration Flight Test 1 that we flew back in, is 2014, right? Yeah. December 5th, 2014. Is a lot of those the same console positions for EM1?
Yeah, a lot of them are the same console position for EM1. I think so. Like I said, the Exploration Flight Test was, like what you said, a good flight test to just see how things operate post the shuttle.
Yeah.
So a lot of positions are the same. Some more. I think so. A few got added on more. I can't tell you specifically, not to my knowledge, but I think so. A lot of them are the same.
Okay. So how about the training and the simulations? Are those? I mean, they sound rigorous. Are they really tough?
Yeah, they're really tough. Like I said, prior to going to it, you go through a rigorous amount of training because even prior to these paper sims or our simulation that we do go through, the same scrutiny is applied there versus that, so you have your mentors and you work with your team there. But if your mentor or your team lead doesn't feel that you're ready to be put in the sim there, you would not be put in the sim there because, of course, you fly how you train. So if you're not putting in the work to train or show your proficiency or your excellence there, you're not going to be put in that seat to flight there. So we take the same mentality versus training. So if you're not ready to be put in a sim, they're not going to put you in the sim and there. So as on that aspect, it is rigorous training because it kind of puts a lot of responsibility on the individual, like myself there, to make sure that I not only know the technical stuff, but I'm also working on my communication, make sure I'm concise. And that you can do that to various outlets where, you see these ISIS flight controllers, and a lot of us, we sometimes just shadow the ISIS flight controllers. Like, can we just sit down with you and hear how you talk? How do you talk to flight director there? And just pick up little stuff and ask questions. Like, cool, how would you ask this? So I agree with you. So the training and the sims are very rigorous. Like I said, they try to make sure that you're the top of the top before they put you in that seat for sims, because I think so leading up to that is training for flight.
Yeah. Well, man, I can hear your passion as you're explaining this, and I think you're going to be in the room with the best of the best for sure.
Thank you so much, Jerry.
All right. So before I let you go, I did want to ask, what is going to change between EM1 and EM2? I know the major thing is that's going to be a crewed mission, right?
Yeah.
Yeah.
So besides that, besides of course putting the crew, that adds on a whole nother level of
complexity.
There's so many words that you can apply to complexity, but not only that, kind of the design of the vehicle is changing a tad bit.
Okay.
Like now we'll be flying on EUS, and I think so that's a more upper stage vehicle.
Okay.
So you had to kind of change your mentality and how you structure, how you tackle flight, and more constraints are added that you have to be aware of when you're flying there. Like I said, the reason why I'm hesitant because I want to talk more technical stuff, but then again, I know the audience is probably just going to get lost in the words there. So So I think so just adding to is more risk and more constraints to the vehicle there. So those are the two things that will majorly change for EM1, from EM1 to EM2, that you have to be cognizant about.
Yeah, a lot of challenges ahead, but I'm glad that you're the person that's going to be tackling them.
Thank you so much.
Mohammed, thanks so much for coming on and explaining what you do and this great missions that we are looking forward to.
Thank you so much, Gary. Thank you for taking time out to interview me.
No problem, man. All right, awesome. Can't wait for EM1. We have one more to go. Who's our last guest?
Okay, last is Macretia Ali Barujo. She's the Deputy Division Chief of Business and Information Systems Services in Human Health and Performance.
All right, quite a mouthful.
It is.
Yeah. All right, let's go right ahead to that talk. She had a great conversation about leadership and her experiences there and how she translates those skills. So, Alex, take us through that final wormhole. Macretia, thanks so much for coming on. You have an interesting story of kind of moving around and transferring these skills from one place to another. So where did you start here?
I started my career many years ago in the 90s, in the mid-90s. I started out as a ISS flight controller before we were even flying ISS. So I had the privilege at that time to become one of the very first mission control specialists for my system for data systems. So that's how I started my career here at NASA.
All right. What was data systems? What were you focusing on?
Focusing on computer networks and all of the software on board the International Space Station. Because we built the space station as a puzzle or in pieces, it was a very huge undertaking to perform all of the upgrades needed to continue to expand the ISS.
Because it was constantly
Right.
changing, yes.
So as ISS was changing, so was software changing, so was hardware changing. So with every module, we were bringing on new networks and new computers, and we were upgrading and expanding the communications and data systems as we went. So our responsibility was to make sure that all the upgrades took place. And those upgrades we upgraded via the ground because we didn't have any big storage devices on board at that time.
Yeah.
It's different now. So we had to orchestrate everything from the ground. So it was a lot of ground testing, a lot of integration with other centers, KSC, Marshall, of course here in Houston with her contractors. So it was a really great opportunity to work with international partners and so many people. I never would have imagined that I would have worked with the number of people and the different types of people that I worked with that early on in my career. So it was a good experience for me.
Definitely. And it sounds like, though, with your role being trained as one of the first flight controllers to look at data systems, it kind of gave you this new perspective that you could pass on to others. So that's kind of where you transitioned to. Were you mentoring and training and that sort of thing?
Absolutely. I think you hit the nail right on the head. It was almost you were a specialist in your area, but you really were expected to transfer that knowledge to enable that consistency of cognizance and that high degree of technical competency to others who were coming on later. So I quickly had to learn some key leadership skills.
All right. So then you now you're training some people and you're developing these leadership skills. I'm guessing people took notice of that, right?
Absolutely. I had some very good mentors early on. I would say that my first branch chief that I had, he was an amazing leader. He taught me to pay attention not only to what's going on technically, but to also understand and develop some understanding of culture and what's working in the organization, what doesn't work in the organization, who's excelling in the organization. So he really gave me some insight on how to get stronger as a leader, and he just helped me in networking altogether. So that really helped me just as a stepping stone to where I would continue on later.
So would you say that the mission control and the flight control has kind of its own culture?
It really does. It's a very interesting place. It's quite amazing, by the way. And if anyone that's ever worked in the front room in mission control will tell you there's really nothing like it.
Wow.
The communication scheme is tailored for that room. The energy in the room is it has its own energy. You can feel it when you walk into the room, but it's very, very technical, and yet it's very formal, and it has a caring feel to it because you're there to take care of that vehicle and ultimately to make sure that the crew succeeds.
Yeah.
And that ownership, and it's your responsibility. And when you're in that chair, if something happens that's related to your system, you have nowhere to deflect. It's your responsibility. So you have to have that component of leadership ownership to be able to sit in the chair and make the decisions to help the mission succeed.
Right. This culture of accountability, but also collaboration.
Absolutely.
Because, yes, you're responsible for that system, but you have so many people helping you.
Absolutely. And you have to draw on the expertise of everyone in the room, while respecting that, of course, the flight director is the ultimate decision maker.
All right. So what are some of those cultural elements that you sort of pass on when you're mentoring others, what sorts of advice and tips do you give them to help them succeed in that environment?
Well, definitely, you hit on one of them. Accountability is one of the most important things. Being present, being accurate, having quality work, being timely. And certainly if you do not understand, ask the questions early on so that you don't get to the end of your training flow or to the most important parts and not have the information or knowledge that you need. So I would say accountability is one thing. And establishing your network too as well. None of us can do this together. It takes alone. It takes teamwork. This is a huge team effort. And to think that you can do it alone is incorrect in this environment. So certainly encouraging people to rely on the team. Various people have different expertise. So identify what those expertise are and lean on those people so that you can get stronger in those areas. So accountability and teamwork. Also technical competency. You have to have a certain degree of technical competency in the environment to really survive and really be seen as a contributor in the team. So you have to then know yourself, identify your strengths, identify what drives you, try to find something in your system or something around that really interests you, that you have a passion about, so that you become really, really good at doing that one thing so that you can then shine. So those are just a couple of things I always share with people. And then one important thing I always share with them is to keep the lines of communication open with your team and especially with your management. I often tell people that your managers are very busy. I'm busy a lot, but it doesn't hurt for you to sometimes come in and let me know what you're doing for me.
Yes, that kind of openness.
Yeah.
Because it's that team environment translates to just the communication within the organization as well, not just in the room. Do you find yourself kind of transferring these skills to your personal life too? Because it sounds like they're very transferable, this idea of open communication.
It's funny that you would ask that because my husband used to work here and he was actually the first African-American flight director that we ever had here at NASA Quatsi. Ali Barujo. So, and I worked with him on console, believe it or not, as an Odin officer. And so I worked with him on console. But we often have a conversation that some of the leadership tenets and skills that we learn here at NASA, we use them in our day-to-day lives.
Yeah.
We really do. And in rearing our children, that accountability, responsibility. I'm constantly talking to them about being a team player, being accountable, and making the decision making. I'm constantly talking to my son, who's 11 years old, about how important it is to own it and really be transparent. So absolutely, yes, I do that.
You have to do it. This works in mission control. You have to do it. So this, it sounds like you've taken these skills and sort of just, you learn them, you develop them, you're bringing them into your own lives. Is that, then you started transferring to other places and bringing these skills to all different parts of JSC, right? So where'd you go next after this data systems?
I was data systems team lead. I became a branch chief in the same area.
All right.
What was interesting about that branch chief assignment, I was a station flight controller at first. And when I became a branch chief, I was a branch chief in the data systems area. And at that time, we had both shuttle and station component. So I was very familiar with shuttle because of my experience in assembly in building the International Space Station. However, I'd never managed a shuttle team before. So that was somewhat of a challenge for me. But the leadership aspects of the job, I learned very quickly the leadership aspects of the job were very similar. There were just some key things I needed to understand about processes and the way things worked in the shuttle culture to really help me be a better leader for them. But leading people, the keys for leadership work no matter what team you're leading.
There you go. You just take the same leadership skills and apply them to, okay, how does this culture work? What is this team like? How can I kind of insert myself into this world and let them trust me and kind of guide them.
Absolutely.
All right. So then you, again, you're rocketing right up. You're branch chief now.
So I was branch chief for data systems.
Yeah.
I then moved over. We like to reorg here at NASA. So we reorged, and what we did, we saw that shuttle was going to be ending soon. So a few years prior to that, we wanted to get out in front of that from emission operations and create opportunities for people to do cross-pollinate and do other things so that when shuttle retired, they would have different skills.
Okay.
So what we did is we combined flight control and training. They were two separate organizations, but we put them together. And so then my new organization brought the astronaut trainers in, flight control trainers in, along with flight controllers. Now, it's all the business of flight operations, but they're different perspectives from a training or instructing perspective. And then you've got the flight control perspective there, and you have shuttle and station. So I took a role over in the communications and data systems for station. But in that role, it was ISS, all ISS, but training and flight control. And so I did that, same thing, using some of the same skills, learning some new skills to go along with it. Because the big challenge in that one, there was a lot of change going on. And people were concerned about the shuttle retirement.
Sure.
So I had to quickly develop trust of the team, and I used a lot of transparency in working with that team. I found that just telling them what I knew really, really helped to keep the team gelled together and with the other leadership skills. And from there, I went off to headquarters, and I did a temporary assignment in a program assessment area. And that was an amazing opportunity. I got a chance to work with some of the high-level leaders, the AAs. I sat on the APMC, took notes for the APMC at the agency level, and it really gave me a perspective of what funnels from JSC and other centers up to headquarters. So while that was somewhat of I was a glorified secretary assignment. It really exposed me to the matters that were discussed, the behaviors of the top level leaders of the agency, the big concerns that were being worked. And I had the privilege of being there when Constellation was being discussed and decisions were being made.
I see.
So I saw a lot. I heard a lot. I learned a lot.
Okay.
In that experience. And then I came back here to the center after a year of doing that, and I accepted a rotational assignment over in the OCFO, and I was the deputy division chief for the Central Budgets Office. So I learned more about budgets and how money funnels into this center.
Okay.
And I worked with that team to help resolve some things that were going on in the team, help improve some processes. So I was really proud of my support that I provided to that area. And after that assignment was over, MOD at the time, which is now FOD, offered me an assignment to go over to the electrical power system. I was there for 3 years, and then I moved over to environmental systems to help with some leadership challenges that were there. And I just sounds like I'm moving around, but
they wanted you to move so you can fix it.
I spent 4 years in the environmental systems. And when things started feeling like they were running smoothly, I think I started getting a little bit bored.
Oh.
And so I was feeling like I needed another challenge.
Yeah, fix it, move on.
And so I moved on. I applied for and was selected as the Deputy Division Chief of the Business and Information Systems over here in Human Health and Performance.
All right, and that's your current role now.
That is my current role.
And it's brand new for
you,
journey.
Right? Yeah.
Yeah, what a journey. It sounds like that's what it sounds like. It sounds like you went to an area, you kind of developed this system of leadership, and here's how things are working, and then kind of made it run efficiently, and then you moved on and you fixed another area. So those like you said, I think the big takeaway here is those leadership skills are transferable. They are extremely transferable.
They transfer to any industry. It really is its own competency. I heard we had a directorate chief many years ago. His name was Alan Flint, and he presented himself as a leadership expert. I'd never really heard that before, and that sort of rang with me. And he really instilled in us that while technical is important, and it is, and we are all to be, technically competent, leadership is also important in running a business and being a leader in an organization. It's as important as your technical.
Wow. Okay. So before I let you go, I did want to pick your brain for one big leadership tip that you've taken with you from place to place. What is one of the, maybe a strategy or just an approach that makes your leadership technique successful?
Okay. I think transparency.
Transparency.
Is important. I often communicate. I don't really have an agenda. So there's no hidden agenda. But if there are elephants in the room, if there are things that we need to correct and improve, I'll be very honest with the team about about things that we need to improve in a transparent way. Mm-hmm. So building that trust with your team, being very transparent, is very important. I think how you start with the team is really, really important. And one of my logos is, together everyone achieves more. And that's team.
Yes, and you need trust to have a successful team. Mm-hmm. Fantastic. Macretia, thank you so much for coming on and telling your story and giving me some great leadership tips. And amazing. Such a great story and an amazing career. Thanks for coming on.
Thank you.
All right, Kai, thanks so much for coming on the podcast today and helping me to put this together, introduce our guests. This is kind of cool because it's a brand new format. We see a mashup of all these different areas, and it kind of gives you this nice snapshot of everything going on at the center. So, all of these things going on at once. So thanks again for helping me to put this together.
Thank you, and it was an amazing experience, and we hope everyone learned something today.
Definitely.
Of the space shuttle.
Roger, 0J, and I feel fine.
Shuttle has cleared the tower.
Became a theme for all mankind.
Actually, a huge honor to break a record like this.
Not because they are easy, but because they are hard.
Never Houston, welcome to space.
Hey, thanks for sticking around. So thanks again to Kai for kind of helping bring this together for this special episode for African American History Month. Great celebration, and I'm glad we have employee resource groups here on Center to help us celebrate that. So if you want to know more about what's going on here at Center, that's nasa.gov/Johnson. You can see all of our various events that we have going on here at the Center. Otherwise, you can follow us on social media. Per usual, the NASA Johnson Space Center accounts on Facebook, Twitter, and Instagram. Facebook, it's NASA's Johnson Space Center. Twitter, it's @NASA_Johnson, and Instagram is @NASAJohnson. You can use the hashtag AskNASA on any one of those platforms to submit an idea for the show, and we'll make sure to either make a whole episode out of it or maybe answer it on a future episode of Houston We Have a Podcast. Just make sure to mention it's for the show. So the credits for today, this podcast was recorded on January 31st, 2018. Thanks to Alex Perryman, Kelly Humphreys, and Kai Harris for helping to put this together. And thanks again to all of our guests for coming on the show, Antia Chambers, Gavin Guy, Mohammed Cebu, and Macretia Ali Barujo. We'll see you next week.